Find the points on the interval of theta between 0 and 2 pi where the graph of r equal 1 minus cosine theta are horizontal or vertical. It's always good to draw a sketch. It helps us see what we're doing. It will let us know how many horizontal and vertical tangents we would have. So let's go ahead and do that by first sketching this in rectangular coordinates. So I see I have a cosine theta that is reflected and it is shifted up one. So I'm going to go 1, 2, 3. The period will be the fourth one, which is going to be 2 pi. And so this is going to be pi, and this will be pi over 2, and 3 pi over 2. Now it has a vertical shift up one, so I'm going to draw a dashed line up one. And then normally at 0 the cosine is 1, but we'd be shifted up one, but then we'd be reflected, so we're going to land right there. And then we come to the middle, and then in the next fourth we're at the max, and then middle, and then min. So here is our graph in rectangular coordinates. Now let's go ahead and graph it in polar coordinates. So we know that at 0 we're 0. We'll go ahead, and it looks like we need to go as far as 2 in some places. So let's go ahead and get some tick marks on here. At pi over 2 we need to be at 1. And then at pi we're at 2. 3 pi halves back to 1, and then back to the pole. So we're going to go like this. And we see that we get a cardioid. So if we're looking at horizontal tangents, it looks like we've got one here and one here. Vertical, we got one here, and one here. Now we know that the slope of the tangent to the curve is dy dx, and that is dy d theta over dx d theta. And so in our case, we have y equal r sine theta, but our r is 1 minus cosine theta. And so then that's times sine theta. And let's go ahead and distribute that through, because that might make that a little bit easier to work with. So this is going to be cosine theta, sine theta. So for the numerator, we need the derivative of this. So that's going to be cosine theta. And then minus first times the derivative of the second, that's going to be minus cosine squared theta, plus the second sine theta times the derivative of the first, so that's going to be plus sine squared theta. And then that's going to be over, if we look at x is going to be r, which is 1 minus cosine theta, times cosine theta. If we distribute that through, we're going to have cosine theta minus cosine squared theta. We need the derivative of that with respect to theta. So it looks like we're going to have negative sine theta. And then here we've got a power rule, chain rule. So power out in front, decrease the power by 1, multiply by the derivative of what's inside. So that'll make that a positive. And first we're interested in where the tangent is horizontal, so where the slope is 0. And that would be when our change in y with respect to theta was 0, so that our numerator was 0, but our denominator was not also 0 at the same time, because then we'd have an indeterminate thing and we'd not be sure. So let's go ahead and set this numerator equal to 0 and find the values where that would be the case. And in order to do that, I'm also going to replace this with 1 minus cosine squared theta, because I see that the other two terms involve cosine. So we have dy d theta, and that's going to be negative 2 cosine squared theta plus cosine theta plus 1. And I'm interested in where that equals 0. So as I look at that, I'm going to multiply everything through by negative 1, because I'm going to see about factoring this. So this is going to be 2 cosine theta and cosine theta. And so it'll be 1 and 1, and I want the middle negative, so that's going to be negative and positive. So this will equal 0 when cosine theta equals negative 1/2, or when cosine theta equals 1. Remember, we're interested in the interval from 0 to 2 pi. So where is the cosine negative 1/2 on that interval? And when I haven't done these for a while and I need to think of the trig, I just did a simple unit circle sketch and say, when is the x negative 1/2? Well, right here and right here in quadrants 2 and 3. So I can see that's when theta equals 2 pi thirds or 4 pi thirds. And when is the cosine 1? And I'm from 0 to 2 pi not inclusive, so that's going to be at 0. So at these three places, our numerator is 0, but as I do a quick check, the denominator is not 0 at any of those places except at 0, and it is there. So I don't know that there's a horizontal tangent at that point. I'm going to have to look at that one further, and I will do that after I've found the vertical. But one thing I do know then is there are horizontal tangents at the points where theta equals 2 pi thirds and 4 pi thirds. Let's go up here. Here's 2 pi thirds and here's 4 pi thirds, and that's where we saw our two horizontal tangents. We will continue on the next video with our vertical tangents and looking at our indeterminate one.